Okay, so now we're going to do some example problems about for finding domains and finding zeros of functions. So listing the domain, remember the two rules for domain that you'll mainly see for at least a little while are going to be you're not allowed to divide by 0 and you're not allowed to take the even root of a negative number. So if we look at our function, we're not dividing by anything. There's no denominator anywhere. And we're not taking the even root of anything. So this is going to be all real numbers. So there's no restrictions there whatsoever. Now, and we move on to B, we have g of x equals 7x over x plus 7. So we sit there and we're like, okay, well, we had the two rules again. We can't divide by 0 or take the even root of a negative. So we look and we see a denominator. Well, we need to label our whole denominator. So we see x plus 7. So because we're dividing by x plus 7 is not allowed to be 0. So more importantly, this tells us if we were to solve and put x on one side, so you say -7, you would say x cannot equal -7. So x cannot equal -7. That is a perfect way to write our domain. That's the only value that we're not allowed to have. Now our last thing here, we have the square root of x plus 7. Well, we are not allowed to have a negative number as our inside our square root. So this entire inside part cannot be negative, or in more sense, it has to be greater than or equal to 0. So we would say x plus 7 has to be greater than or equal to 0. Okay, so at this point, just like the other problem, you would subtract 7 from both sides, and you would get x must be greater than or equal to -7. And that is our domain for that. Okay, and then we move on, and we have different scenario where we've got 1 over the square root of x plus 7. And so let's write that a little better. We'll say g of x equals 1 over the square root of x plus 7. So in this case, we have two things going on, so we want to be careful, right? First off, we are dividing, okay? So we're not allowed to divide by 0. So I know that the whole denominator, that cannot be 0. So I've got the square root of x plus 7 cannot equal 0. It's not allowed to happen. Also, I have that I cannot have the even root of a negative number. So x plus 7 has to also be greater than or equal to 0. Well, we'll see an issue here in just a second as we try to figure out what x can be, right? One thing that we can do to try to free up x is we can square both sides. So long as we do the same thing to both sides, it's legal. So if we square both sides, we'll get x plus 7, and x plus 7 is not allowed to be 0. That makes complete sense. And then we would have x cannot equal -7. It's not allowed to be that. So keep this in mind. Now over here, we would solve and get x has to be greater than or equal to -7. Well, these almost agree, except for at -7. One of them says x can't be that. The other one says x can be, but it can be that or greater. Well, you always go to the one that is, you're going to go with the smaller one. They have to both agree. So in order for these both to agree, we are not going to allow our number, we're not going to allow our domain to have the number -7 in. So when we put these together, we get that x has to be greater than -7. So this is our grand number. Now, as we move along, we have our last one. So we'll call this f of x equals tangent of x. Well, two things we're not allowed to do. Remember, we can't take an even root of a negative, and we can't divide by 0. So what we need to do is think of tangent as sine of x over cosine of x. If we think of it this way, it's pretty clear to see that we are dividing by cosine. So cosine of x cannot be 0. So we have to figure out what x values create that, right? That goes back to our unit circle. So in this case, we have x. X is not going to be allowed to be 0 plus 2 pi k or 2 pi, or excuse me, no, incorrect, sorry, pi over 2 plus 2 pi k or 3 pi over 2 plus 2 pi k. Now we can actually combine these together to create pi over 2 plus pi k, but you can make that simpler if you want. But basically, if x is pi over 2 or pi away from that in any direction, you're going to end up not having a tangent value, so you're not going to be able to have those. Now, let's talk about finding zeros. So remember, all we really have to do is set our equations equal to 0 and solve them. So 7x plus 4, you set them equal to 0, and you solve. So you subtract 4 from both sides. Get 7x equals 4, negative 4, and then divide by 7 on both sides. And you get x to equal negative 4 sevenths. Well, that's the only 0 that we have. That's all that's going to exist. For the next example, we have x squared. It's possible for us to have 2 zeros. But we could have 0, or we could have 1. Now, actually, technically, you can't have 0 zeros. It's not going to happen with a quadratic. You're going to at least have 2 imaginary ones. But anyway, we will move along and say, how do we go about solving this? Well, we could do the quadratic formula, or we could actually factor. And if you did the quadratic formula, you would find that x would be negative 3. There's actually only 1 0 for this. So again, the quadratic formula is perfect for this because you have a quadratic. Now this next one creates a little bit of a trick. You've got x cubed plus 3x. You're not allowed to use the quadratic formula, but you have 2 terms. So what you need to do in this type of situation is you want to turn this addition into multiplication. How do I turn this into a multiplication problem? Well, I need to find out what's common to both terms. So the one thing that's common to both terms is an x. If I removed the x from x cubed, I would have x squared. And if I removed the x from 3x, I would have a 3. Now this creates a multiplication. We're multiplying this by that, which when we have this equal to 0, we can split this up. We can say, okay, either x equals 0 or x squared plus 3 equals 0. Now this is an interesting issue here because this is a 0 and an intercept. This, however, is not, right? This will create 2 imaginary numbers because if we go up here, x squared plus 3 equals 0, we would get x squared equals negative 3, and so x would equal positive or negative I times the square root of 3. Now, we'll work on this later as far as how you get your quadratic formula to give you these answers, but all of these are zeros to our function. However, this is the only intercept that you'll see. Now, if tangent of x equals 0, now this is where, when we talked about earlier, how this to be sine of x over cosine of x. Now, when we talked about domain restrictions, we only looked at our denominator. But for our zeros, the only thing that matters is our numerator. So in this case, we're going to look at when does sine of x equal 0. Well, this is going to occur at 0 plus 2 pi k, or at pi plus 2 pi k, which, just like the other problem that we worked on earlier, would be the same as having pi k. So these answers are slightly different, dealing with these different scenarios, just understanding where to look for zeros, how different strategies that you can take, and what to do with trig functions.